Hey everyone, have you ever wondered, how did water, the simplest molecule in the universe, come to shape everything we know from stars to cells to civilizations? While you are thinking, comment down below. Where are you in the world right now? And what time is it for you? Maybe it's midnight, maybe it's dawn. Wherever you are, this moment is yours. Now dim the lights, let the screen fade into the background, let your breathing slow. This isn't just a bedtime story, it's a journey through time, science, and the hidden story of water, from the birth of oceans to the edge of the quantum world. And along the way, you'll see how water connects not only atoms but life itself. Before there were oceans, before there was Earth, before even the sun burned its first rays into the solar system, there was water. Not in the form you know it. No lakes, no raindrops. Just molecules drifting in deep, interstellar space. Tiny clusters of hydrogen and oxygen atoms forming in the cold void between stars. The story of water begins over 13 billion years ago, shortly after the Big Bang. The early universe forged hydrogen in massive quantities, and as stars began to form, some of the massive, short-lived giants lived fast and died in violent explosions known as supernovae. These explosions scattered the heavier elements they had created, like oxygen, across the cosmos. When oxygen met hydrogen in the vast clouds of space, the first water molecules were born, not in pools or rivers, but as thin films of ice on dust grains, tiny fragile specks floating in deep space. These ice grains gathered into clouds, then into clumps, then into worlds. In our own solar system, around 4.6 billion years ago, the young sun was forming, surrounded by a swirling disk of gas and dust, what scientists call the protoplanetary disk. Inside this chaotic spiral, planets were taking shape. Earth, just a ball of molten rock at the time, was far too hot to hold water. So where did Earth get its oceans? Most scientists believe that water arrived here from space, carried by icy comets and asteroids crashing into the early Earth. Each impact delivered just a little bit of water, but over millions of years it added up until oceans began to form and clouds began to rise. By the time Earth cooled and settled, it had become a blue planet, covered in water, an alien ocean on a newborn world. And here's a strange truth. Every drop of water you've ever touched is older than the Earth itself. The water in your tea, your tears, the waves at the shore. It was all formed long before our planet even existed. In a very real sense, you are drinking the stars. Water's story doesn't start on Earth. It starts in the heart of dying suns, across light years of cold space, stitched into the very fabric of our planet's birth. It is ancient, it is alien, and it is everywhere. But what happens when this ancient traveler meets life? That story begins. If the universe wrote a recipe for life, water would be the first ingredient. It's easy to take it for granted, this clear, tasteless liquid that flows through rivers, falls from clouds, and pours from taps. But beneath its simple appearance lies a molecule so extraordinary, so essential, that without it, life as we know it would not just struggle, it would be impossible. Let's take a step back. Imagine the young Earth, some 4 billion years ago. The surface was a chaotic mix of volcanic activity, lightning storms, and searing heat. But something miraculous was brewing in the puddles, the oceans, the hot springs, something that would eventually become us. In those waters, the first organic molecules began to form, chains of carbon, hydrogen, oxygen, nitrogen, linking, breaking, reforming. Simple molecules grew into complex ones. Over time, under pressure and chance, these chemical dances gave birth to self-replicating structures. This was the dawn of life, and none of it could have happened without water. But why water? What makes it so special? Water is an unusual molecule. It's small, just 2 hydrogen atoms bonded to 1 oxygen atom, but its structure gives it unique powers. It's polar, meaning one end of the molecule is slightly negative, while the other is slightly positive. That might sound technical, but this tiny detail is everything. It allows water to stick to itself, to pull itself up trees, to dissolve more substances than any other liquid known to science. This is why water is called the universal solvent. It carries nutrients, minerals, and even information from cell to cell, from ocean to cloud, from life to life. Every living thing on Earth, every plant, every animal, every cell in your body is made mostly of water. Your brain is about 75% water. Your blood over 90%. Even your bones contain water. It flows through your veins, fills your lungs, cushions your organs, and enables every biochemical reaction your body performs. Without it, your heart couldn't beat, your thoughts couldn't form, and your cells would collapse. Inside the microscopic world of the cell, water is not just a passive background. It's the medium in which life swims. Proteins fold and twist into their functional shapes in water. DNA, life's blueprint, relies on water molecules to stay stable and replicate accurately. Enzymes catalyze reactions in its presence. Ions flow through watery channels to send signals through nerves and muscles. Water is not just a part of the process, it is the process. And this relationship between life and water isn't just limited to Earth. It guides our search for life beyond our planet. When astronomers point their telescopes toward distant moons, exoplanets or comets, the first question they ask is there water? Because wherever we find water in the universe, the possibility of life lingers close behind. Take Europa, one of Jupiter's moons. Beneath its icy surface lies an ocean possibly larger than all of Earth's combined. Or Enceladus, a moon of Saturn, which shoots water vapor into space like cosmic geysers. Or Mars, where ancient riverbeds and polar ice caps whisper of a wetter past. In every case, water is the clue, the trail left behind by life, or maybe the cradle where it's just waiting to awaken. But even here on Earth, water continues to surprise us. Life has been discovered in boiling acid springs, in frozen Antarctic lakes, and deep beneath the ocean floor where sunlight never reaches. In each of these harsh environments, life clings to water as its lifeline. Even the simplest organisms, bacteria that have never seen the sun, depend on water's unique properties to survive and grow. And here's something to consider. Life doesn't just exist in water, it emerged from it. Our own evolutionary history can be traced back to ancient fish-like creatures that swam in primordial seas. Over millions of years, some of them crawled onto land, their bodies adapting to a new environment. But even now, long after we've left the oceans behind, we carry the signature of water within us, in our cells, our tears, our bloodstreams. When a baby is born, it floats in amniotic fluid, a salty liquid not unlike the ocean. It's a reminder, perhaps, that we are still creatures of water, no matter how far we travel from it. Water is not just a resource. It is not just something we use. It is part of what we are. It connects us, nourishes us, sustains us. It links the primitive slime of Earth's earliest life to the digital pulses of the modern human brain. It is the thread that weaves through the fabric of all living things. And yet, for all its importance, we often overlook its magic. We reduce it to a commodity, a number on a bill, something to be bottled and bought. But if we stop and really look, we begin to see that every drop of water carries with it, not just atoms and molecules, but history, biology, and miracle. We've followed water from the stars to the cells, but what about the world itself? The mountains, the valleys, the rivers that shaped our landscapes. In the next chapter, we'll see how water sculpted Earth like a patient artist, carving continents, moving mountains, and building the stage upon which all life performs. Let's keep flowing forward. Long before there were maps, cities, or even forests, before animals crawled or plants took root, there was water. And it was not waiting to be used. It was already busy sculpting the face of the Earth. Water is more than just a passive liquid. It is a force, a shaper of worlds, an architect with time on its side. Give it a drop and a crack, and it will become a river. Give it a crack and a mountain, and it will wear it down to sand. When Earth first cooled, water covered it like a shroud. It filled the lowlands and spilled into the cracks of the still-forming crust. These early oceans, restless and wide, began to set the rules of engagement between land and liquid. Waves pounded, tides pulled, and rains began to fall from the first clouds. The Earth was not still. It moved, buckled, rose, and sank. Tectonic plates, massive slabs of Earth's crust, floated and shifted atop a molten mantle. Water seeped into every fault line, every fracture, and where water met rock, it changed the rock forever. Rain fell onto bare volcanic landscapes, slowly breaking down minerals through chemical weathering. This isn't just erosion, it's transformation. Water doesn't just carry rock away, it alters it, pulling atoms out of minerals and forming new substances like clay. Over thousands, then millions of years, water wore down the planet's surface. Mountain ranges that had once erupted violently into the sky were slowly crumbled by wind, snow, and rain, carried away grain by grain into the rivers below. Rivers, perhaps water's most elegant invention. They are not just moving water, They are moving earth. Every river is a conveyor belt, lifting silt, sand, and soil and dragging it down to the oceans. But they do more than carry. They carve. The Grand Canyon in the United States is over a mile deep, and it was carved not by explosives or earthquakes, but by the patient persistence of the Colorado River. Just water. Just time. And then there are glaciers, the slow-moving giants of ice. When snow falls and never melts, it becomes compacted, layer after layer, until it becomes glacial ice. Over centuries, glaciers grow thick and heavy enough to move under their own weight. They grind across continents like colossal bulldozers, scraping bedrock, reshaping valleys, and leaving behind lakes and ridges in their wake. The smooth U-shaped valleys of places like Norway, Alaska, or the Himalayas are water's footprints in frozen form. But water doesn't just shape the surface, it affects the inner workings of the earth as well. Deep beneath our feet, water trapped in the crust and mantle plays a role in volcanism. It lowers the melting point of rock, fueling the creation of magma. When volcanoes erupt, part of their fury can be traced back to water, a hidden driver of explosive power. Even earthquakes are not free from water's reach. As water seeps into faults and fractures, it lubricates tectonic boundaries. In some cases, it reduces friction, allowing slow slippage. In others, it contributes to sudden, violent releases of energy. Entire landscapes can rise or fall in seconds, all from the tensions built in stone and stirred by water. Caves form where underground water dissolves limestone, creating hollow chambers and winding tunnels that stretch for miles beneath the surface. Stalactites and stalagmites, stone icicles and pillars, form from mineral-laden drips that took centuries to fall. These are time sculptures, born from persistence. Even deserts, seemingly dry and lifeless, were shaped by ancient waters. Fossilized riverbeds lie beneath the Sahara. Salt flats tell stories of vanished lakes. Wind-blown sand dunes are made of grains once carried by rivers long gone. There is no place on Earth that hasn't been touched by water, past or present. And let us not forget the oceans, the great pulsing hearts of our planet. They are constantly reshaping coastlines through tides, waves, and currents. Coral reefs grow and erode. Islands rise from volcanic vents and are slowly swallowed again by the sea. Tsunamis, powerful walls of displaced water, have altered entire regions in mere moments. Water's impact is not just physical, it's chemical. It cycles endlessly through what we call the hydrological cycle. Evaporation, condensation, precipitation, infiltration. But this cycle is more than just weather. It's a geological loop, redistributing minerals, carving canyons, forming deltas, and influencing the climate itself. Without this global cycle, Earth's surface would be a barren crust. It's the planet's great circulatory system. Over billions of years, water has reshaped Earth again and again. Continents have collided, split, and drifted. Sea levels have risen and fallen. Ice ages have advanced and retreated. And through it all, water has never stopped moving. Think about this. The water in your glass today may have once flowed through the gills of a trilobite 500 million years ago. It may have sat in the belly of a dinosaur. It may have helped shape the cliffs of Dover, filled the Nile during the age of the pharaohs, or frozen in a glacier that carved Yosemite Valley. Every drop has a memory. Every drop is a sculptor. We walk on land, but the land itself was shaped by water. Hills, valleys, beaches, mountains. These are not just natural features. They are water's artwork. And it is still at work even now, carving, crumbling, carrying. In the next chapter, we'll see how humanity entered this grand stage, and how water guided not only the landscapes we lived in, but the civilizations we built, the wars we fought, the myths we wrote, and the futures we dreamed of. Water shaped the world. Now we'll see how it shaped us. Imagine this, thousands of years ago. A small group of people gather by the edge of a river. The sun is high, the soil is rich, and the water flows endlessly, shimmering in the light. They build their shelters near its banks, plant seeds in the moist earth, and learn to read the seasons by the rise and fall of the water. They don't realize it yet, but they are starting something immense. A village, a culture, a civilization, and at the heart of it all is water. Water isn't just a substance, it's a force that has bound humanity together since the dawn of our species. It has quenched our thirst, fed our crops, powered our tools, inspired our gods, and shaped our societies. It has been our greatest ally, and at times our most terrifying enemy. Every great civilization in human history was born by water, not near water because of it. Consider Mesopotamia, often called the cradle of civilization. The name itself means land between the rivers, the Tigris and the Euphrates. These rivers didn't just provide drinking water, they were lifelines, bringing fertile silt during floods, enabling irrigation and supporting agriculture that allowed cities to grow. From these waters came the world's first writing, law codes, and complex governments. To the west, the Nile gave birth to ancient Egypt. For over 3,000 years, pharaohs ruled along its banks. The river rose like clockwork every year, flooding the land and leaving behind rich black soil that Egyptians called Kemet, the Black Land. Their entire worldview, economy, religion, and even the placement of the pyramids were shaped by the river's sacred rhythm. In the east, the Indus Valley civilization rose around 2500 BCE in what is now Pakistan and northwest India. The Indus River and its tributaries nurtured vast cities like Mohenjo-Daro and Harappa. These cities were marvels of early urban planning, with complex drainage systems and public baths, a testament to the intimate relationship between water and hygiene, order and civic life. And then there was China. The Yellow River, or Huanghe, was both the cradle and the curse of early Chinese civilization. Its floods could be devastating, earning it the nickname China's Sorrow. But without it, there would be no ancient Chinese dynasties, no Confucian texts, no Great Wall. Human beings took the risk of settling near its banks because water, even in chaos, was always worth the gamble. The same story played out again and again. The Greeks gathered around springs and built aqueducts to bring water into their city-states. The Romans took it further, engineering vast networks of aqueducts that stretched for miles, bringing clean water to their baths, fountains, homes, and toilets. Roman water infrastructure was so advanced that some of it still works today. Their engineers even developed pressurized lead pipes and invented tools to measure water pressure. In many ways, the Roman obsession with water cleanliness and comfort rivals our modern systems. In South America, the Inca carved channels through mountains and developed terraced farms that used water wisely in high altitudes. In Central America, the Mayans built massive reservoirs and channeled rainwater into underground limestone caves, cenotes, which they treated as sacred. Human ingenuity, from every corner of the world, bloomed when it learned to partner with water. But this bond was more than technical. It was deeply spiritual. Across cultures and millennia, water has always been more than physical. It has been divine. In Hinduism, the Ganges River is a living goddess. Ganga Ma, bathing in its waters, is said to cleanse sin and release the soul. In Christianity, water represents rebirth through baptism. In Islam, ritual washing, wudu, prepares the body and soul for prayer. In Japanese Shinto traditions, waterfalls are believed to be sacred spaces where spirits dwell. In indigenous cultures across North America, water is often seen as a living relative, honored, respected, and protected. Water is woven into our myths too. The great floods, the deluges, appear across ancient stories. Noah and the Ark, the Epic of Gilgamesh, Manu in Hindu tradition. All these myths reflect a deep recognition of water's power to cleanse and destroy, to end and begin again. As humanity grew, so did our relationship with water. Trade routes formed across rivers, lakes, and seas. The Silk Road may have connected east and west over land, but it was water that connected continents in earnest. The Indian Ocean, the Mediterranean, and later the Atlantic became highways of exploration, trade, conquest, and migration. But where water united, it also divided. Wars have been fought over it. Kingdoms have risen and fallen by their ability to control it. The building of dams, the digging of canals, the staking of riverbanks, these acts were as political as they were practical. Control the water and you control the people. Even today, water lies at the heart of geopolitics. Nations argue over rivers that cross borders. Megacities wrestle with shortages. Some countries build massive desalination plants. Others battle drought with emergency tankers. Rural communities migrate. Economies falter. All because of the movement or absence of water. And yet, we are slow to listen. Despite millennia of dependence, our modern world has pushed water into the background. We pipe it in, bottle it, buy it, waste it. We poison it with plastics, chemicals, and industrial runoff. Rivers are dammed, wetlands drained, aquifers depleted. It is a quiet crisis, and one that grows louder each year. But even now, the bond between human beings and water has not broken. In fact, it is evolving. Cities are beginning to rewild their rivers, turning concrete canals into green corridors. Communities are organizing around watershed protection. Technology is advancing, bringing us smart irrigation, water recycling, and decentralized treatment systems. Even our laws are changing. In some places, rivers and lakes are being granted legal personhood, the right to be protected, to be heard in court, to exist for their own sake. And still, despite all our progress, the basic truth remains: we need water. Not just to live, but to be human. It defines our survival, our culture, our faith, our cities, our future. If we were to strip away the noise of modern life, if we paused, truly paused, we would hear it, the sound of our shared history flowing just beneath the surface, the whisper of ancient rivers, the rush of sacred waterfalls, the steady drip of memory. It is the sound of water calling us back to balance, to reverence, to responsibility. Because in every civilization, no matter how far it advances, the story always returns to the same truth. No water, no life. No life. No water, no us. And so the story flows forward. In the next chapter, we'll explore how water became not just a source of survival, but a source of power, fueling machines, transforming economies, and shaping the modern world in ways no ancient civilization could have imagined. From sacred to strategic, water's journey continues. Water. For thousands of years it was the lifeblood of survival, the breath of early civilization. But then came a moment in our history when water became something else entirely, something more powerful, more mechanical, more transformative. It became an engine, not just a drink or a river to farm beside, but a force we could harness, direct, and convert into energy. Water became a partner in progress, a driver of machines, and a silent architect of the modern industrial world. The transformation began slowly, as all revolutions do. Before the rise of great empires or bustling cities, early humans had already begun to understand water's mechanical potential. When they watched rivers pushing logs downstream, or saw pebbles turning endlessly in the current, they must have wondered, what if we could use that force? And so came one of the earliest inventions, the water wheel. The water wheel was a deceptively simple innovation, a wheel turned by flowing water, no fire, no fuel, no oxen required. In ancient Greece, the water wheel was used to grind grain. In China, it pumped irrigation water uphill. The Romans improved the design and industrialized its use in mills throughout their empire. With water, they could grind tons of wheat per day, a task that would take scores of people by hand. For the first time, water replaced muscle as a source of reliable, renewable energy. But water's rise to industrial stardom would come centuries later, during the 18th and 19th centuries, when the Industrial Revolution took hold. Britain, rich in rivers and rainfall, became the perfect landscape for water-powered innovation. Mills were built along fast-moving streams, and massive water wheels powered spinning jennies and looms. Entire textile towns like Manchester were designed around the flow of water. The countryside began to buzz, not just with the sounds of nature, but with the mechanical rhythm of industry. Still, humans weren't done improving water's role in production. The key breakthrough came with hydraulics, the science of using pressurized water to perform work. Engineers realized that when water was forced into tight, confined spaces, it could exert massive force. This principle was harnessed in hydraulic presses, used for shaping metal, lifting loads, and powering tools. A single drop of water under pressure could move mountains, or at least build them. Water also entered the chemical world. As industry diversified, it wasn't just power that water offered, it was a medium, a solvent, a chemical carrier. In brewing, tanning, dyeing, and metallurgy, water was central to transformation. You couldn't extract ore, purify salt, create pigments, or refine sugar without water. It became the invisible partner in every recipe of industrial chemistry. And then came steam. It's ironic in a way. The moment that seemed to liberate us from dependence on rivers, steam power, was also a new form of water's dominance. Steam engines, like those perfected by James Watt, turned water into vapor and vapor into motion. With this invention, humans no longer needed to build factories next to rivers. Now water could be boiled anywhere. Coal provided the heat, but it was still water expanded, contained, and released that turned the gears of the Industrial Revolution. Trains thundered across continents, powered by boiling water. Factories churned through day and night. Steamships crossed oceans. This was water made mobile, water made mechanical. Even in modern electricity, water is at the center. Hydropower is one of the oldest and still most widely used forms of renewable energy. Dams like the Hoover Dam or China's Three Gorges are cathedrals of modern engineering, gigantic humming fortresses of concrete and steel. But their power is simple: falling water. Gravity pulls it down, and turbines spin. The energy of elevation becomes electricity. lighting up cities, running servers, powering lives. Hydropower accounts for over 16% of the world's electricity today, and in some countries it is the dominant source. In Norway, over 95% of electricity comes from water. Brazil, Canada, and Ethiopia also rely heavily on this ancient but ever-relevant resource. But water's industrial story is not just about energy, it's about science. In laboratories across history, water has been the universal solvent, the starting point for experiments, a medium for life and a standard of purity. Scientists measure water in moles, in parts per million, in isotopes and hydrogen bonds. It is at the center of chemistry, biology, and physics. Think about this. The periodic table might show over 100 elements, but almost every reaction that happens in nature or the human body occurs in water. Cells are little oceans. DNA floats in cytoplasm. Enzymes function in aqueous environments. Our blood is over 90% water. Every chemical interaction within us, from thought to movement to memory, takes place in liquid. Water is even used to understand the origins of the universe. In astrophysics, one of the key indicators of a potentially habitable exoplanet is the presence of water. Where there is water, there might be life. In biology, scientists use water as the benchmark for all known life systems. In geology, we analyze ancient water trapped in rocks to understand the climate of Earth millions of years ago. In environmental science, water samples tell us about the health of ecosystems. It is not just a resource, it is a lens through which we read the world. And in the world of medicine, water has been equally foundational. In hospitals, distilled water is used in IV fluids, surgical cleaning, and pharmaceutical mixing. In public health, access to clean water has been the difference between life and death. The field of epidemiology, the science of disease mapping, was born in London in the 1850s when Dr. John Snow traced a cholera outbreak to a single contaminated water pump. That discovery transformed our understanding of disease transmission and launched the field of modern sanitation. Today, high-tech industries use water in ways that would astonish our ancestors. In semiconductor factories, silicon chips are bathed in ultra-pure water, so pure that it would strip minerals from your body if you drank it. In nuclear reactors, water is used as both coolant and moderator, controlling the atomic fires within. In space exploration, water recycling is essential. Astronauts aboard the International Space Station drink purified water that once passed through their own bodies over and over again. A closed-loop cycle in microgravity. And even now, in the 21st century, the next wave of industrial progress will depend on how wisely we manage water. From AI-powered irrigation systems in agriculture to green hydrogen production that uses water electrolysis as its base, our future industries will rely on water just as our old ones did. Only now, the challenge is not how to harness it, but how to share it, protect it, and keep it flowing. Because here's the twist. Even with all our advances, we are entering a time when water scarcity may become the greatest industrial threat. Over 2 billion people already live in areas with high water stress. Factories may be forced to shut down, crops may fail, and cities may face rationing, not for lack of money but for lack of water. Suddenly, everything comes full circle. The most powerful engine of human progress turns out to be the most fragile. We can build supercomputers, send rovers to Mars, and split atoms, but without clean flowing water, it all grinds to a halt. The story of water in industry is a story of both triumph and warning. It lifted humanity to extraordinary heights. It built nations, fueled revolutions, and transformed the pace of progress. But now, it asks us a question. Can we move forward without exhausting the very force that brought us here? In the next chapter, we will dive into the looming challenge of our age, climate change, and how water, once again, stands at the very heart of our fate. From rising seas to melting glaciers, droughts to deluges, the climate crisis is not just about carbon, it is about water in chaos. Prepare yourself, because in the next part of our journey, the tide turns. For most of human history, water was a gift, sometimes fickle, sometimes dangerous, but always available. It flowed freely through the veins of the earth, from mountaintops to oceans, from clouds to soil, from aquifers to rivers. We drank it, bathed in it, channeled it, worshipped it. We used it to build cities, grow food, power machines, and fuel empires. But now, as the 21st century unfolds, something has changed. The story of water, once a tale of abundance and ingenuity, is now one of imbalance, urgency, and unfolding crisis. Not in some distant future, not in some faraway land, but now and everywhere. The alarm bells are ringing, and their sound is wet. Water scarcity, water pollution, water extremes, climate breakdown. These are no longer separate issues. They are strands of a single unraveling web. And at the center of that web is us. The growing thirst. Let's begin with the most visceral issue, scarcity. Water scarcity is not about running out of water entirely. There is, after all, the same amount of water on Earth now as there was when the dinosaurs roamed. But only 2.5% of it is fresh water, and most of that is locked in ice caps, glaciers and underground aquifers. What remains accessible, rivers, lakes, shallow wells, is a fragile sliver of the global supply, and our demand for that sliver has skyrocketed. In the past century, global water use has increased by over 6 times, fueled by population growth, industrialization, urban sprawl, and intensive agriculture. We use water not just for drinking and sanitation, but for growing food, raising livestock, manufacturing goods, and generating electricity. Consider this. It takes 2,700 liters of water to make a single cotton shirt, nearly 15,000 liters to produce 1 kilogram of beef, about 140 liters to produce 1 cup of coffee. Now multiply that by 8 billion people. As demand rises, supply shrinks. Over 2 billion people now live in regions experiencing high water stress. In parts of the Middle East, India, South Africa, Mexico, and even the western United States, rivers run dry before reaching the sea. Aquifers are being depleted faster than they can recharge. Wells that once brought up fresh water now cough up dust or worse, salt. The phrase day zero, once fictional, is now real. Cape Town came within weeks of turning off its municipal water taps. Other cities, from São Paulo to Chennai, have faced similar countdowns. In rural areas, the crisis is quieter but deeper. Crops fail, livestock perish, families migrate. This is not just inconvenient, it is existential. Water scarcity triggers food insecurity, economic instability, and conflict. Already there are disputes between states, tribes, and nations over who controls rivers, dams, and aquifers. The Nile Basin, the Tigris-Euphrates system, the Indus River. These are no longer just waterways, they are geopolitical flashpoints. And this is just one part of the crisis. A contaminated world. Now, let's talk about pollution. Water pollution is often invisible, but it is everywhere, flowing through our taps, rivers, and bloodstreams. Industrial waste, agricultural runoff, untreated sewage, heavy metals, pharmaceuticals, and plastic. These have turned once pure water sources into chemical soups. The causes are vast. In developing countries, over 80% of wastewater is discharged without treatment. In many industrial zones, regulations are weak or poorly enforced. Textile factories dump dyes into rivers. Pesticides seep from farms into streams. Oil rigs leak. Landfills leach. Mining operations leave behind toxic tailings. In richer nations, the problem is more insidious. Microplastics, hormone disruptors, and persistent chemicals known as PFAS, forever chemicals, contaminate drinking water. These chemicals are linked to cancer, reproductive harm, and immune dysfunction, and they don't break down in nature. Even pharmaceuticals are now detectable in our water. Antibiotics, antidepressants, birth control hormones, flushed from homes and hospitals, pass through wastewater treatment plants, unequipped to handle them. Aquatic life is affected. Fish are found with intersex traits. Algae blooms explode from nutrient overload, choking oxygen from lakes and killing entire ecosystems. And then there's ocean pollution. Over 11 million metric tons of plastic enter the ocean each year. Water bottles, fishing nets, microbeads, they break down into smaller particles, never disappearing, just sinking deeper into the marine food chain. The ocean, once a boundless symbol of purity, is now a reservoir of our waste. Polluted water kills. Every day, over 1,000 children die from preventable waterborne diseases like cholera and diarrhea. In Flint, Michigan, lead in drinking water poisoned thousands. In Bangladesh, arsenic in groundwater has led to mass chronic poisoning. These are not accidents. They are symptoms of a system that treats water as infinite and indestructible. But the water is speaking. We have only to listen. The climate reckoning, and now we reach the greatest amplifier of all. Climate change. If water is the bloodstream of the planet, then climate change is the fever that destabilizes everything. Rising temperatures are shifting the hydrological cycle, the great ancient dance of evaporation, precipitation, and runoff. That cycle is now breaking down. The signs are everywhere. Glaciers are melting. From the Himalayas to the Andes to the Alps, ancient ice is vanishing. These glaciers feed billions with seasonal meltwater. As they disappear, rivers run dry, and so do communities. Sea levels are rising, swallowing islands, eroding coasts, and salting freshwater aquifers. Cities like Jakarta, Miami, and Dhaka face inundation, mangroves die, fisheries collapse, storms intensify. Warmer oceans fuel stronger hurricanes and typhoons. Rain falls harder in shorter bursts. Overwhelming dams, drainage, and levees. Floods destroy homes and farmland, then disappear, leaving drought behind. Droughts deepen. The rains no longer come when they should. The monsoons shift. El Niño becomes more violent. In parts of Africa and Australia, land that once grew crops now turns to dust. The water cycle is not broken. It's out of rhythm, skewed, unpredictable. It delivers too much where we need less, and too little where we need more. Climate scientists call this hydroclimatic instability. But what it means is simple. Water is becoming unreliable. And when water becomes unreliable, everything collapses. Agriculture fails. Energy grids falter. Cities heat up. Migration surges. Conflict rises. Public health erodes. Insurance markets break. Economies wither. Hope fades. And it's not some distant disaster for our grandchildren. It is now. In California, water rationing pits, almond farmers against city dwellers. In Syria, a prolonged drought helped spark civil unrest and war. In sub-Saharan Africa, families walk for hours to fetch water from shrinking sources. In Europe, even the Rhine and Danube have shrunk to record lows, halting shipping routes. Climate change is water change, and water change is civilization change. Turning the tide? Yet all is not lost. Across the world, engineers, scientists, activists, and communities are rising to meet the challenge. Desalination plants convert seawater into freshwater. Countries like Israel and Saudi Arabia rely heavily on them, but they are energy intensive and create salty waste. Wastewater recycling toilet to tap is becoming more acceptable. Singapore's New Water project is a global model of purification and reuse. Rainwater harvesting, drip irrigation, cloud seeding, and aquifer recharge are being scaled in arid zones. Nature-based solutions restoring wetlands, planting mangroves, reconnecting floodplains are helping buffer floods and filter water naturally. And perhaps most critically, rights movements are growing. In Bolivia, indigenous groups led a revolt against water privatization. In New Zealand, the Wanganui River has been granted legal personhood. In Michigan, residents demand justice for poisoned communities. Water is no longer just a resource. It is a right, a life force, a being. But the window is closing. Unless we fundamentally change how we value, use, protect, and govern water. Unless we shift from extraction to restoration, we will not outrun this crisis. The earth will survive. Water will find its way. But whether humanity moves with it or is swept away, that is the question. Zoom in. No, closer. Past the rivers, past the cells, past even the molecules. Travel deep into the microscopic realm, where atoms dance and forces whisper. There, in the invisible underworld of quantum mechanics and molecular bonds, water reveals a new face, one more mysterious and paradoxical than anything we've seen on the surface. We know water as simple, H2O, two hydrogen atoms bonded to one oxygen atom. A basic molecule. Yet it is this basic molecule that has baffled chemists, physicists, and biologists for centuries. And as we look closer, it becomes clear, water is not just strange, it is exceptional. In fact, scientifically, water breaks more rules than it follows. Let's begin with its anomalies. Water has over 70 known physical anomalies, more than any other known substance. Anomalies that aren't just trivial curiosities, but that shape life and nature in profound ways. For example, water is most dense, not at freezing, but at 4 night. This means ice floats, a property essential for life in lakes and oceans. If ice sank, every winter would see water bodies freezing from the bottom up, trapping and killing ecosystems. Life, as we know it, could not survive. Then there's surface tension. Water's surface tension is higher than most other liquids, strong enough to hold droplets intact, pull water up tall trees, or let small insects walk across its surface. The reason? Hydrogen bonding. Are hydrogen bonds the key to everything? Water molecules are polar. The oxygen atom has a slight negative charge, and the hydrogen atom's a slight positive one. This makes water a tiny molecular magnet. Each molecule can bond to up to 4 others through weak electrical attractions called hydrogen bonds. These bonds are fleeting, lasting just picoseconds, but they are numerous, forming a constantly shifting network that gives water its cohesion, viscosity, and structure. These bonds cause water to expand when it freezes, to absorb heat without drastic temperature changes, and to act as the universal solvent, dissolving salts, sugars, gases, and even proteins with ease. But it gets weirder. Under supercooling conditions, water can remain liquid below freezing, sometimes down to -48 degrees, without turning to ice. Under pressure, it behaves unpredictably, sometimes becoming denser, sometimes less. Water exists in at least 20 different forms of ice, each with its own crystalline structure, depending on pressure and temperature. Ice can be soft and fluffy like snowflakes or hard and dense like the exotic Ice 7 found in the interiors of icy planets. And then there is liquid-liquid phase transition, a theory that suggests water may exist in 2 distinct liquid phases under extreme conditions. A high-density liquid and a low-density liquid, coexisting and flipping between forms. If true, this would make water the only known liquid with such behavior. But to truly grasp the mystery of water, we must go smaller still to the quantum level. At this scale, water defies intuition. Quantum tunneling, where particles like protons pass through barriers they shouldn't, has been observed in water's hydrogen bonds. These bonds are not just dynamic, they are quantum fluid networks, capable of reorganizing with astonishing speed. And the behavior of electrons in water is still not fully understood. When high-energy radiation strikes water, it creates a storm of reactions. The breakdown of molecules, the formation of hydroxyl radicals, and the sudden appearance of solvated electrons, free electrons that float in the liquid, momentarily stabilized by the cage of water molecules. These short-lived particles are essential to radiation chemistry and medical therapies like radiation cancer treatment, where water in our cells becomes a reactive agent. Even in biological systems, water is not passive. Inside cells, water is structured, not random. It surrounds proteins in special hydration shells, affecting how they fold, move, and function. Enzymes rely on specific patterns of water to work. DNA's double helix is stabilized by water molecules nested in its grooves. In fact, water may be involved in quantum biology, a controversial but growing field exploring how quantum effects influence life. In photosynthesis, for example, plants move energy through light-harvesting complexes with near-perfect efficiency. Some researchers believe that water helps maintain quantum coherence, allowing energy to move like a wave rather than a particle, exploring multiple paths simultaneously. If true, water is not just a solvent, it is a co-conspirator in the very process of life. Let's not forget proton hopping, a unique behavior in water, where hydrogen ions, protons, don't just drift through the liquid but hop rapidly from one molecule to the next. This forms the basis for pH, acidity, and countless biological reactions. This hopping mechanism, known as the Grotthuss mechanism, allows for fast proton transfer, a property crucial to enzyme catalysis, nerve conduction, and cellular respiration. Water, in this light, is not static. It is alive with motion, structure, and potential. It is a dynamic quantum network, pulsing with interactions far beyond simple chemistry. And yet, for all our study, we still don't fully understand it. Water is not fully understood. That sentence should stop us cold. Despite being the most studied substance on Earth, essential to life, omnipresent in the universe, and foundational to physics, chemistry, and biology, water remains, in many ways, unsolved. A puzzle wrapped in a molecule. And the implications ripple outward. In planetary science, the search for extraterrestrial life is built on the search for water. Europa, Enceladus, Mars, all these celestial bodies may contain liquid water under their icy crusts. But what kind of water? What structures? What behaviors under alien pressures and temperatures? In climate science, understanding how water vapor behaves in the atmosphere, how clouds form, and how precipitation varies requires better models of water's microscopic dynamics. The future of weather prediction, disaster response, and environmental protection depends on better water science. In nanotechnology, water is not just a background material. It becomes a tool, a constraint, a medium of design. Lab-on-a-chip devices, molecular computing, and precision medicine, rely on manipulating water at atomic scales. In medicine, water is the key to understanding hydration, cellular mechanics, drug delivery, and aging. New imaging technologies like ultra-fast X-ray scattering and neutron diffraction are revealing how water moves in tissues, crosses membranes, and carries messages between cells. And perhaps the most exciting frontier, synthetic biology and origin of life studies. Researchers are recreating early Earth conditions to understand how life arose. Water is central, not just as a solvent, but as a sculptor of possibility. Its unique ability to self-organize, to form hydrogen bonds, to concentrate molecules and drive reactions. These may be the conditions that birthed metabolism, replication, and complexity. Some scientists believe that life may have started in hydrothermal vents, deep ocean geysers powered by geothermal heat, surrounded by mineral-rich water. In these underwater crucibles, gradients of temperature and acidity, driven by flowing water, could have powered the first energy cycles of life. And so we come full circle. From the vast rivers that shaped continents, to the molecular interactions that shape proteins, water is the thread that runs through every chapter of existence. Its story is written in the slow carving of canyons, the pulsing of cells, the roaring of waterfalls, the silent bonding of molecules. It is told in the thundercloud and the snowflake, the tsunami and the tear. And as science peers deeper, we are reminded again and again, water is not just simple. It is the most complex, simple thing in the universe. The final frontier is not just space. It is understanding water, because in that understanding may lie the secrets of life, time, and consciousness itself. Human civilization stands at a watery crossroads. We have seen how water built our world, how it shaped biology and industry, how it now teeters under the weight of scarcity and pollution. But this is not where the story has to end. In the quiet before the next storm, in the sun glinting off a rain barrel, in the hands of a child turning on a tap, a different future is still possible. Because water, even in crisis, is not only a challenge, it is also an opportunity. Around the world, innovators, scientists, farmers, engineers, policymakers, and communities are rising to meet this challenge, not just to survive but to thrive. Their solutions, varied and evolving, represent a new chapter in the human-water relationship, a chapter written in resilience, ingenuity, and most importantly, in hope. The rebirth of water technology. Let's begin with what humanity has always done best. Invent. New technologies are reshaping how we source, purify, store, and distribute water. No longer dependent solely on rainfall or rivers, we are learning to make water. Desalination, once a luxury of oil-rich nations, is now being revolutionized. From solar-powered desalination units in off-grid villages to graphene filters that remove salt at the atomic level, clean water can now be pulled from the sea with ever lower energy costs. Countries like Israel recycle nearly 90% of their wastewater, turning sewage into irrigation water and industrial supply. Atmospheric water generators, devices that pull moisture from the air, are already in use in arid regions, providing drinking water in refugee camps and drought-stricken communities. These devices once required huge amounts of energy. Today, some are powered entirely by solar panels. Smart water grids are being deployed in cities like Singapore and Amsterdam, using sensors and AI to track leaks, monitor quality, and optimize flow. This reduces waste and saves billions of gallons annually. Just as we revolutionized electricity with smart meters, we are now doing the same with water. Biomimicry offers another frontier. Inspired by the Namib desert beetle which collects dew on its back, engineers are designing surfaces that harvest water from fog and mist. Materials inspired by lotus leaves repel contaminants, making self-cleaning water filters possible. Then there's nanotechnology filters made of carbon nanotubes or nanosilver particles that remove pathogens, heavy metals, and even microplastics. What once took industrial plants to purify can now be done with a straw in a backpack. Imagine a future where everyone has a device that turns any source, river, rain, or puddle, into safe drinking water. These are not pipe dreams. These are realities, some already deployed, others scaling rapidly. But technology alone isn't enough. We must also change how we think about water, redefining the value of water. For too long, we have treated water as either free or cheap. It flows from the tap with no sense of cost, until it doesn't. Economists call this an externality, a resource undervalued because its depletion or degradation carries no direct price. That is changing. Cities and countries are beginning to price water not just for its volume but for its value. Water markets are forming where farmers can trade water rights during times of drought. Dynamic pricing models charge higher rates for excessive use, while subsidizing basic access for the poor. But price is not the only tool. Legal frameworks are evolving too. In 2010, the United Nations recognized access to clean water and sanitation as a human right. Since then, over 100 countries have rewritten constitutions, laws, or policies to guarantee water to all. Indigenous communities have gained stewardship over ancestral water sources. Rivers like the Ganges, the Wanganui, and the Atreto have been granted legal personhood, a radical shift in how we relate to nature. The idea is simple yet profound. Water is not a commodity. It is a kin. Sustainable agriculture and industry. Agriculture consumes about 70% of global freshwater. That means we cannot talk about the future of water without transforming the way we grow food. Precision irrigation, which delivers water directly to the roots of crops, is being adopted globally. Drones and satellites now scan fields to measure moisture levels, guiding farmers on exactly when and where to water. Some use soil sensors that transmit real-time data to smartphones, allowing them to act before a single drop is wasted. Hydroponics and aeroponics, growing plants without soil, using nutrient-rich mist or water, can reduce water use by up to 90% compared to conventional farming. These systems are powering vertical farms in urban centers, bringing food production closer to cities and slashing transport costs. In industry, water-neutral factories are emerging. Companies like Coca-Cola and Nestlé, once criticized for their water use, are investing heavily in water stewardship, returning as much water to the environment as they extract, often cleaner than it was before. In short, we're learning to close the loop, to recycle, reuse, and respect every molecule. The power of collective action. At the heart of all this change is not a machine, it's a mindset. Across the globe, citizens are taking action. In South Africa, communities in Cape Town dramatically cut water use when faced with day zero, proving that conservation is not just technical, it's cultural. In India, women-led water committees in villages have revived ancient stepwells, capturing monsoon rains for year-round use. In California, artists have painted sidewalks with stormwater pathways. In Bangladesh, school children monitor water quality in local ponds. In Kenya, tech startups connect boreholes to cloud-based apps that show villagers when pumps are working and when they're not. And in each of these actions is a profound truth. Water connects us all. When one well runs dry, a village suffers. When one river is polluted, thousands are affected. But when one community finds a solution, others can follow. Water crises may be local, but their solutions can ripple outward, changing the world. Hope in a changing climate. Climate change will continue to challenge us. There will be droughts, floods, and uncertainty. But the future is not written in stone, it is written in water. And that script is still being edited. By embracing resilience, diversity, and adaptation, societies can learn to live with variability rather than against it. Green infrastructure like rain gardens, bioswales, and permeable pavements can turn cities into sponges, not surfaces. Restored wetlands can act as natural buffers against floods. Forests can regulate rainfall. Mangroves can shield coasts from storms. More importantly, education must flow like water into every school, every boardroom, every village. The next generation must grow up not just learning the water cycle, but understanding the water crisis and how to be part of the solution. A future written in water. We often say water is life, but it's also a mirror. It reflects who we are, what we value, and where we're going. Do we see a world where clean water is a luxury for the few, or a right for all? Do we invest in water as infrastructure, or treat it as an afterthought? Do we wait for rivers to vanish, or do we restore them before they are lost? The answers are not easy, but they are within reach. Because the flow of the future is not fixed. It is shaped drop by drop by the choices we make today. And just as rivers can be redirected and storms anticipated, the path ahead can be one of regeneration, not ruin, one of balance, not collapse. If we listen to the whispers of water, to the pulse of nature, to the wisdom of science, and if we act boldly together, then the story of water can still end not in scarcity but in abundance, not in despair but in hope,